Hello, everybody. I hope you're doing well. I just encourage you, hang in there. Keep on working on these. The test is coming up soon. And we just need to keep trudging along because the payday is coming. And after it's over, we can kind of relax a little bit in our AP classes. So do your best. Try to make sure you're understanding the concepts, not just memorizing the steps that I'm doing. This is 2014, question number 5. And let's read this. Twice differentiable. So we know the first and second derivative exist everywhere for both functions. And clearly the table gives you values. I'm not going to mark all those down. So part A, x-coordinate, relative minimum of f. And it's over the whole interval. All right, in order to have a relative minimum, we have to find the place where the derivative changes from negative to positive. And the other option is if the second derivative is negative, if the first derivative is 0 and the second derivative is positive, that means we have a relative min. And if the, sorry, my brain, trying to think. If the first derivative is 0 and the second derivative is negative, we have relative max. Hopefully I said that right. So we're looking at the function f. And let's observe a couple of things here. So our potential points would be here and here. We have the first derivative 0 at those points. And let's take a look. The derivative changes from negative to negative. It doesn't change. So therefore, nothing happens there. And then we have negative to positive. So clearly, in this column, where x is 1, we're going to have a relative minimum for f. So let's write that down. F has a relative, whoops, that dot's in the wrong spot, it's over there. Relative minimum at x equals 1, and you need to give a reason, because f prime changes from positive to negative at x equals 1. I don't know how to write. Okay, so that's it for question number 1. That was actually pretty easy. Let's look at part B. Why must there be a value of c? There must be a value of c between negative 1 and 1 where the second derivative is 0. So there's two ways this could possibly happen. Either the intermediate value theorem or the mean value theorem. So the intermediate value theorem would say if you find the second derivative at a point, I'll show you. So look at that. If the second derivative is negative to the left of c and positive to the right of c, then you know that it had to cross 0. That's assuming it's continuous. But if we look at this, we're not given the second derivative anywhere, so we can't do that. So the only other way is going to be the mean value theorem, and I know I've done this a million times, but I'm going to explain the mean value theorem. If you have a function that's continuous and differentiable, so I'm going to just draw a random function that is continuous and differentiable. Then, if you find the slope between the endpoints, that's the average rate of change, that's going to be f of b. Whoa, that is so bad. So bad. F of b minus, let me zoom in here, f of a over b minus a. That's the slope of that red line. Then it says, mean value theorem says, there must be a point on your graph where the slope of the tangent line, or in other words, a derivative, and let me give you more details, at some point C, so it's going to be at that point. That would be our C, if the graph looked like that. So that's what it's saying over here. There must be a C in that interval where the second derivative equals that. Well, the second derivative is a slope of the first derivative, and this is the first derivative graph, if that's what we're looking at. So we are going to be looking at the first derivative and finding slopes between points of the first derivative. And if at any point the slope is 0 between any of those 2 points, then there must be a point where the slope of the tangent line, or in other words, the derivative, is 0. And we have it. Hopefully you see it. We go from 0 to 0. The y value goes from 0 to 0 of the first derivative. Therefore, the slope between those points clearly will be 0. So we have everything we need. Let's explain all of that. So first we need continuity and differentiability. So this says twice differentiable. So we can say f prime is differentiable. Therefore, f prime is continuous. So we have differentiability and continuity. Now we need to show that the slope of our secant line, average rate of change, is 0 somewhere, and clearly between these 2 points. So we're going to say f prime at 1 minus f prime at -1 over -1 minus 1. No, 1 minus -1, sorry. Let me erase that. Whoops, I'm making it worse. 1 minus -1 is 0. So we have the average rate of change of 0. So we are done. We've shown everything necessary. We have differentiability. We have continuity. We have the average rate of change of 0. Therefore, and this is the beautiful part, you will copy all of this right there, because they want you to prove that statement. Well, that's your conclusion. There must be a value of C for, all of this. For C in the interval from -1 to C, between -1 and 1, such that the second derivative is 0. That would be the end of part B. That's going to be the mean value theorem. Make sure you understand that. Just don't memorize that. If you can visualize this picture I've shown you here, you understand that picture, you understand that concept, then that won't be a hard problem. That's a very common problem on a data table type of situation. Let's get to part C. Part C. The function h is defined as that, ln of f of x. So we want to find the derivative of h at 3. Okay, this one I like because it's pretty straightforward. So we're given h of x is ln f of x. Hopefully you see it's a function inside of another function. It's going to be chain rule, and that's the inside function box. So the question will be, what is the derivative of ln of anything? 1 over that. Well, if it's the variable. So the derivative ln of box will be 1 over box times the derivative of box. And we want to find h prime at 3. So plug in 3 everywhere. And just go to the table and find that. F prime of 3, we see right here is 1/2. And f of 3 is 7. So leave your answer like that. That is fine. You don't have to simplify that. If you choose to, which you shouldn't, you should get 1/14. Party! Party! Woo! All right. How do we do this problem? Remember, there is no product rule for integration. You can't just integrate them separately. There is no rule like that. So you have to recognize when you have a situation like that, you can only rewrite it possibly and make it into a single function, which we can't here, but we can do a U sub. You see, we have a function inside of another function. So the function on the inside, 99 times out of 100, will be your U. Then we take the derivative of that. Now here is the beautiful part. I want this. I have that. That is wonderful. So what's going to happen here? This gets replaced with U. And this gets replaced with du. Now here's the problem. These are values of x. We know that because x's are variable. Therefore, those are x's. This is u, our variable in this case is u. So I need to change these to u's, because it has to match up or it's wrong. So when x is -2, I solve for u. U is g of -2. Well, we look at our table. G of -2 is -1. I like that. Nice and simple. Oh, whoa, 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 whoa. Okay, and then we have to check our other point. The upper bound is 3 when x is 3, u will be g of 3, which is, we look right here, g of 3 is 1. So our upper bound is 1. This is so beautiful. Now we get u squared over 2 is the antiderivative of u. And according to the fundamental theorem, we're going to plug in 1 and then -1. So we get 1 squared over 2 minus -1 squared over 2, which clearly is 0. But that's not the answer. I messed up somewhere. I don't know where I messed up. Oh, whoa, whoa, whoa. I know what oh, whoa, Yoshida, you're an idiot. Sorry. Man, I wasted so much of your time right now. I am so sorry. When I substituted, I lame-o'd big time. So I'm going to have f prime of u, du. I forgot the f prime. So, all that work for u, I could have left it. When x, -2, u will be g of -2, and we said g of -2, we already did that, is -1. And then when x is 3, g of 3 was 1. So we're going to go from -1 to 1. I hope that's right. Yeah. Now, sorry. What's the antiderivative f prime? Clearly, it's just f. Because, how do you check? You take the derivative of your antiderivative, and it should equal your original, and the derivative fu clearly is f prime u. So we are in good shape. This is f of 1 minus f of -1. And we look at f of 1 and -1. So it's going to be 2 and 8. It's going to be 2 minus 8, which is -6. That is it. Hopefully that problem wasn't too bad. Just make sure you kind of follow the steps, understand the concepts that are going on, and apply the basic rules that we know. All right, that's it for number 5. Off to number 6.